Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate we have kind of a standard understanding of what periodic functions are. So now we're ready for the next level. And what we're going to look at is we're going to look at how our unit circle can actually be modified to apply coordinates. Because remember, it is a circle in a coordinate plane. But in order for us to find these coordinates, we need to revisit some of trigonometry concepts or topics that we may have forgotten. The first one is SOHCAHTOA. So this is the relationship of sine, cosine, and tangent. So that's where the SOH is here, opposite over hypotenuse. Adjacent over hypotenuse. Notice tangent does not use the hypotenuse. So these are the three trigonometric ratios that you studied in a previous course. And so we just abbreviate it as SOHCAHTOA. This is our mnemonic device that we use to help us remember this relationship. Now let's look at our unit circle. Now remember, what makes this our unit circle? It's a unit circle because the radius is 1. Now, if we have an angle or some coordinate up here, we have an angle that's inscribed with reference to the central point here. So it's a central angle. So I'm going to draw an arbitrary triangle. So suppose we have some point right here. If we draw what's called a reference triangle with respect to the origin to this angle and the x-axis, we create a nice right angle. A right triangle. So let's take this right triangle out. Now this is the unit circle. So what is this distance here? This is the radius of the circle. Well, if this is the unit circle, then what is the radius? The radius is 1. Now this point, whatever it is going to have a coordinate. It's going to have an x coordinate, which will be this distance down here. And it'll have a y coordinate, which is this distance there. So we can use these trig relationships here to figure out what these angles are, these dimensions are. Let's start with x. Which of these ratios could we use that could create a relation between x and the hypotenuse? The answer is cosine. So we would say the cosine of this angle is adjacent side, which is x over 1. This means the cosine of the angle is the x-coordinate. So that means the cosine of whatever the angle is going to give you the x-coordinate. Let's try y. Which trig relationship here would help us find the y-coordinate? Hopefully you see it's going to be sine. The sine of our angle is going to be the side opposite of the angle, which is y, divided by the hypotenuse, which is 1. So this means the sine of our angle is y. So this means any point on the circle will have an xy coordinate, but it can be found by calculating the cosine or the sine of the angle, this reference angle with respect to the x-axis. We now have a connection between any point on the unit circle, its ordered pair, to the angle that it creates. So we can take the cosine of the angle, and that's the same as the x-coordinate of this point. We could take the sine of this angle, and that's the y-coordinate of this point. And we're going to use this relationship to build sine functions, cosine functions, and tangent functions.